Good morning, dear students. In yesterday's lecture, we have learned about the normal distribution, and before that, we have learned about the Poisson and the binomial distribution. In today's lecture, we are going to learn about the Z transformation, p value, and two aspects, that is the laws of probability. Okay, so we'll start with the Z transformation. Okay, Z transformation, a random variable that is Z, which has a normal distribution with mean mu is equal to 0. A random variable z which has a normal distribution with mean mu is equal to 0 and the standard deviation is equal to 1 is called standard normal distribution. In yesterday's lecture we have seen this, and the curve is called standard normal curve. Okay, we have learned about the standard normal curve. Okay, so tables giving the areas under the standard normal curve are available for free radios. Okay, you are going to use these tables later on for your calculations of these hypothetical values in chi-square test, t-test, and z-test, all these things. Okay, but in present things, it's a ready-made table given with all the values. We have to just check and get it from that table. Total area bound by a normal curve and the x-axis is 1. In yesterday's normal distribution graph, that bell-shaped graph, what we have seen, the total area bounded by the normal curve and the x-axis is 1, okay, or 100%. The area which comes under the curve is the 100%, and on the x-axis we can calculate it as 1. Okay, so in the center there is a mean, and from the left side some values are there, and right side. Okay, if we have to calculate area under the curve, just listen properly. If we have to calculate area under the curve that falls between the 2 points on the x-axis, for example between xa and xb, we can make use of the table after transforming the normal variable x to a standard normal variable z using the formula. Okay, so in this case what you are going to do is that you are going to see the values which are there between any 2 points, that is the a and b of on the x-axis. Okay, between these 2 points you are going to find out how much area is covered. Okay, just get the graph in front of your mind, in your mind, and you will can think over that bell-shaped graph. On the x-axis, if you'll see, these 2 points are there, a and b, and if you want to calculate the area, for example, you have seen that for what you can say, the standard deviation 1, for sigma 1, that area is almost comes to some 33 point something it was coming, so total 68%. Okay, and then sigma 2 it is 95%, and sigma 3 it is coming on almost around 90 9.7%. So like that, if you want to calculate area between a and b, these points, you can transform these values into z formula. Okay, you can make use of the tables after transforming your normal values x to standard normal variable z using the formula z is equal to x minus mu divided by sigma. Okay, where z is equal to standard normal variable, mu is the mean, sigma and standard deviation. Okay, so x are the number of variables. Okay, so variable number, what, from where, which point to which point you have to calculate. This is known as the z transformation. Okay, so we can see it with the help of one example, simple example. Okay, so in this example you can see the weight of a rohu was found to be normally distributed with mean at 500 grams. Okay, rohu is the name of fish. Okay, when you are doing some aquaculture activity in a pond, what they used to do, they have to decide when they can remove the fish. Okay, so mostly they get good price when the fish reaches to 1 kg plus weight. Okay, if you remove it earlier, you will get less price. Okay, so every time they have to remove the fish from the pond and just check what is the weight of that, average weight of that fish. So like that, when they have weighed the fish, sample fish, the weight of the roe was found to be normally distributed with mean at 500 gram and standard deviation of 50. As we have understood that standard deviation is the deviation from the mean. So all fishes are not 500 grams. Okay, some fishes are 550 grams, some fishes are 520 grams, some fishes are 450 grams. Okay, so the standard deviation is 50. Find the standard normal variate of rohu with 520 gram. So if you use this formula, you can understand how much number of rohus will be with 520 grams. It's a probability. Okay, it is not the approximate value, but to get an idea about all these things, you can use this particular formula. Okay, so weight is equal to x, that is the 520 gram. We have to find out the x, that is the 520 gram. Now the mean is, the given mean is 500 grams. Okay, so mu is 500 gram, and standard deviation they have already given, that is the 50 gram. So you'll, if you'll put it in the z transformation formula, z is equal to x minus mu divided by sigma. So it will come around 520 minus 500 divided by 50. So 20 minus 20 divided by 50 will, is equal to 0.4. So chances of getting 520 gram of fish in a catch of this particular time will be 0.4 out of the 1. Okay, so it will come around 40%. 40% fishes will be of 520 grams. Have you understood? So this is how you can calculate with the help of graph by converting it into the Z transformation, Z value. You can get the values which are required for you. Okay. So this is, first of all, you should understand, those who have not understood, probability is just you are predicting. Okay. By whatever data you are having with you, on the basis of that, you are just predicting that with this particular weight, this much fish will be there. Okay, so it is always not like that, that whatever results are there, they are 100% matching with the probability results. Probability gives you an idea of occurrence of that event. Okay, if it is not, it has not occurred, after that also it will give you an idea about how much probability or chances of occurring that event in this particular manner. Okay, so that is the views, and that's why we have learned in the probability distribution, this particular thing is used in many business models. Now next is the p-value. When we perform a hypothesis test in statistics, a p-value helps in determining the significance of our results. Okay, now in last years, I think paper number 1 SYBSC, you have learned about the research. Okay, in that the importance of hypothesis. Okay, so when you are doing some or other kind of research, you have to first hypothetically write the statement. Okay, hypothetically, instead of what you can say, you have to get the direction in that. On that direction, you have to do the research. So that is a statement which you write at the beginning of the research, and that is called as hypothesis. Okay. फॉर एक्झाम्पल, जर तुम्ही विचार केला तर तुम्हाला असं लक्षात येईल की तुम्ही एखादी गोष्ट रिसर्च करण्यासाठी घेतली असेल आणि तुम्ही काय म्हणता की ह्या गोष्टीचा एंड किंवा रिझल्ट हा असा असेल. ओके, सो दॅट हायपोथेसिस यू राईट समटाइम्स अँड अकॉर्डिंग टू दॅट यू स्टार्ट वर्किंग. So whatever available evidences are there, observations are there, on the basis of that you do some assumptions, and according to that you write a statement that is called as hypothesis. So when we perform a hypothesis test in a statistics, now you have to check whether this hypothesis is right or wrong. Okay. Okay, whether it is agreeing the whatever observations you are having, according to that the hypothesis is going right or wrong, that you have to test. When we perform a hypothesis test in statistics, p-value helps in determining the significance of our results. Okay, whatever results we are getting, whether it is they are signifying or not, for that the p-value is very important. So hypothesis tests are used to test the validity of a claim that is made about a population. If you are predicting something, you are writing something, that claim whatever you are having, whether it is right or wrong, or valid or invalid, that is governed by the p value. The claims that is on trial is called the null hypothesis. Okay, so on the basis of trial, you are writing the null hypothesis. The alternative hypothesis is the one we accept if the null hypothesis is concluded to be untrue. Okay, if the null hypothesis is untrue, we have to reject the null hypothesis and we have to accept the alternative hypothesis. Okay, so we are going to learn this in the next, when we are studying about the this chi-squares test, z-test and the t-test. Okay, all these hypothetical tests are there, that we are going to do it in the practicals also and in theory also. But in whether it is signifies the hypothesis, or it is the valid hypothesis, that is decided by uh, calculating the p-value. The evidence in the trial is the data that the statistics go along with it. Okay, so all hypothesis tests use a p-value to weigh the strength of the evidence. So what the data tells about the population will be governed by, or will be decided by the p-value. Okay, so the term signifies significance level of significance, or you can say level of significance, that is alpha, is used to refer to pre-chosen probability, and the term p value is used to indicate a probability that can calculate after given study. Okay, so we have to compare whether the whatever results you have got, they are more than p value or less than p value. According to that, we have to decide whether we have to accept the null hypothesis and reject the null hypothesis. Okay, so if your p value is less than the chosen significance level, whatever we are going to sit down there, what is the significance level? If your p-value is less than the chosen significance level, then you reject the null hypothesis. Listen it carefully. If your p-value is less than the chosen significance level, so which are these significance level? It may be 5%, or that is 0.05. P-value should be more than or less than 0.05, or then 1%, 0.1% level of significance. If in that significance level, if it is less than and more than that, then we, according to that, we have to reject and accept the null hypothesis. If the p-value is less than the chosen significance level, then you reject the null hypothesis. P-value should be more than significance level, then you accept the null hypothesis. Then you reject the null hypothesis. That is, accept that your sample gives reasonable evidence to support the alternative hypothesis. Okay, how to write hypothesis, that we are going to learn in the that chi-square test and all. The choice of significance levels at which you reject H0, that is the null hypothesis, is arbitrary. Conveniently, the 5%, that is less than 1 in 20 chances of being wrong, can be level of significance. You can take level of significance is 5%, even 1%. म्हणजे 20 जे रीडिंग घेतले त्यातला एखादा रॉंग आला तर आपण काय म्हणू शकतो, ठीक आहे, की कुठला तरी एरर असेल किंवा बाय मिस्टेक झाला असेल, किंवा ते ती लेवल ऑफ सिग्निफिकन्स ही आपल्याला आता जितकं तुम्ही लेवल ऑफ सिग्निफिकन्स कमी कराल तेव्हा तेवढं तुमचे रिझल्ट्स काय असणार आहेत, ॲक्युरेट असणार आहेत. जसं कंपनीमध्ये एखादा प्रॉडक्ट तुम्ही तयार करताय आणि तुम्ही लेवल ऑफ सिग्निफिकन्स जर काय ठेवला, 10 ठेवला, तर काय होऊ शकतं की तुमचा जो माल असतो तो डिफेक्टेड मोठ्या प्रमाणात जाण्याची शक्यता असते. त्यामुळं म्हणजे जेवढी तुमच्या प्रॉडक्टची काय म्हणता येईल की सिव्हिअरिटी आहे, म्हणजे फॉर फॉर एक्झाम्पल जर तुम्ही ड्रग्स घेतले असतील, म्हणजे औषधं घेतली असतील, तर त्या कंडिशनमध्ये लेव्हल ऑफ सिग्निफिकन्स खूप एकदम मायन्यूट ठेवावं लागेल, म्हणजे 0.0.001 ह्याच्यापेक्षा पण कमी ठेवावं लागेल आपल्याला लेवल ऑफ सिग्निफिकन्स. कारण अशा कंडिशन हे काही लाईफ थ्रेटनिंग काही काही ड्रग्ज असू शकतात, त्याचे साईड इफेक्ट असू शकतात. मग त्या ठिकाणी क्वालिटी कंट्रोलमध्ये जेव्हा तुम्ही एखाद्या कारखान्यामध्ये जाल, इंडस्ट्रीमध्ये जाल आणि त्या इंडस्ट्रीमध्ये प्रोडक्शन होत असेल, तर त्यातला जो प्रोडक्शन करणारा माणूस वेगळा असेल, रिसर्च करणारा वेगळा असेल आणि क्वालिटीचं चेक करणारा जो माणूस असेल, तो काय सगळे स्ट्रिप्स उघडून त्यातली गोळी टेस्ट करणार नाही. तो 100 मधनं रँडमली काही पॅकेट हे करेल आणि त्यावेळी त्याला लक्षात येईल, की अरे हे भरपूर पॅकेटमध्ये डिफेक्ट यायला लागला आहे. देन ही हॅज टू रिमूव्ह, यू हॅव टू चेक ऑल द लॉट, वॉट एव्हर इज प्रोड्यूस. If he's not getting, hardly he is getting one, or in 1,000 he is getting one or two, then they will go ahead with the production. Okay, so to check the quality, in the same case, if we are doing some production which doesn't have big uh, what you can say, and it's not, it doesn't have big deal with the life. Okay, and the price of the product is also very less. In that conditions they afford to do some minor errors. तुम्ही बरेचदा बघितलं असेल की काही वेळा आपल्याकडं जे ह्याचा कपड्यांच्या दुकानात डिफेक्टिव्ह हे येतात, माल येतो. तुम्ही बघितल्यानंतर तुम्हाला लक्षात येतं की बटन वर खाली आहे किंवा त्याला कुठेतरी होल पडलेला आहे. तर असा माल पण ते काय करतात, मग कमी किमतीमध्ये काढतात. तर तो जेव्हा चेक करत असतील, जेव्हा कपड्याच्या फॅक्टरीमध्ये किंवा याच्यामध्ये, त्यावेळी त्यांना लक्षात येतं की अरे एका दुसरा आहे, ठीक आहे, तो आपण काय करू शकतो, रिप्लेस करू शकतो. खरं जर भरपूर प्रमाणात फॉल्ट्स असतील तर त्यांना काय करायला लागेल, तर त्यांचं लॉसमध्ये होईल. सो टू रिमूव्ह ऑल these errors, they have to consider the level of significance. They have to do the this chi-square test, hypothetical testing they have to do, so that they can go ahead with their product or the research. Okay, whatever. So level of significance, actually the choice of significance level at which you reject the H0 is arbitrary and conveniently the 5%, that is less than 1 in 20 chances of being wrong, 1%, and 0.1% p is less than 0.05, 0.01, and 0.01 levels have been used in the industry. Okay, probability. Now, what is probability may be defined as the relative frequency or probable chances of occurrence of an event or an average. For example, giving birth to female in the first pregnancy, getting in first pregnancy, if the females have bonds, female babies are born, what is the chances? In natural probability it is 50 to 50-50%. Okay, एक तर मुलगा असेल किंवा मुलगी असेल. Getting a head when unbiased coin is tossed is half or 50%. Okay, both sides it is same. So when you are tossed, getting whether it is head or tail, the chances is 50%. Probability is denoted by, it is denoted by symbol P, and its value ranges from 0 to 1. Okay, so uh, the value of the probability, as we have seen earlier also, it ranges from 0 to 1. Okay, so if it comes to very close to the 0, that means the chances of occurring of that event is it's not no chance of occurring that event. And if it reaches to perfect 1, that means 100% the chance of occurring that event. Okay, so 0, so in this particular formula you can see 0 in between the probability it is more than 0, and it is less than 1. So p is equal to 0 means it's impossible event, whereas p is equal to 1 means it is the certain event. Okay, 100% it will occur. Suppose an event E can happen in m different ways out of total of n different equally likely ways. Then the probability of occurrence of an event denoted by P or PE is given by P is equal to P raised to E, number of favorable ways, to E divided by total number of equally likely ways. Okay, so this is the formula. No need to remember it, but you can remember the formula. P is equal to m divided by n. Probability of non-occurrence of the event. We have learned this also earlier. Occurrence of the event E is denoted by Q, is given by Q is equal to n minus m divided by n, is equal to 1 minus m divided by n is equal to 1 minus p. That's why p plus q is equal to 1. Okay, so number of occurrence of event is equal to p, that is the probability, and not occurrence of this event is the q. Okay, so p plus q is equal to 1. Probability of occurrence of non-occurrence of an event is equal to 1. If probability of blood group being Rh negative is 1 out of 10, then the probability of Rh positive is 9 out of 10. Either it is Rh negative or it is Rh positive. Only two chances are, two possibilities are there: Rh negative and Rh positive. If Rh negative it is 1 out of 10, then Rh positive is its 9 out of 10. I hope you have understood this concept. Okay, so there are some laws of multiplication of probability and addition of probability. So addition law of probability: if two events cannot happen simultaneously, that is occurrence of one event uh, precludes the occurrence of other, such events are called the mutually exclusive events. For example, in tossing of a coin, we get either head or tail. Birth of a male excludes the birth of the females. Okay, only one event can occur at a time. For example, that we have seen the tossing of coin and the birth of male and female. जर मेल जन्माला येत असेल तर फिमेल होण्याचे चान्सेस नाही आहेत. फिमेल आले तर मेल होण्याचे चान्सेस नाहीत. दे आर एक्सक्लुझिव्ह इव्हेंट्स. ओके, सो ब्लड ग्रुप ऑफ अ पर्सन कॅन बी ए or B or AB or O. All these events are mutually exclusive events and they follow the addition law of probability. Total probability of these events will be equal to the sum of the individual probabilities. Okay, so let A and B are two mutually exclusive events with probabilities PA and PB respectively. Okay, the probability of occurrence of at least one of these two events denoted by P in bracket A plus B is given by PA plus B is equal to PA plus PB. Okay, the word or is given used when addition is applied. Okay, and if when you are using multiplication, then you have to use, instead of or, you have to use and. Okay, so example, probability of getting a male child is half and that of female child is half. The probability of getting male and female child is half is equal to 1. A pond contains 180 fishes of rohu, 200 fishes of katla, and 120 fishes of mrigal. Okay, three fishes: rohu, katla, and mrigal. 180 fishes of rohu, 200 fishes of katla, and 120 fishes of mrigal. So total number of fishes 500. Find the probability that fish randomly selected is rohu or katla. What are the chances of getting रँडमली सिलेक्टेड? तुम्ही नेट टाकला आतमध्ये आणि त्यातनं येणारे फिश हे रोहू किंवा कटला असू शकतील, याची प्रोबॅबिलिटी किती आहे, हा प्रॉब्लेम आहे. सो लेट्स इव्हेंट ए सिलेक्टेड फिश इज रोहू, इव्हेंट बी सिलेक्टेड फिश इज कटला. इव्हेंट ए अँड बी आर म्युच्युअली एक्सक्लुझिव्ह. रोहू मिळत असेल तर त्या कॅचमध्ये कटला मिळेल काय? नाही मिळेल. So all both the events are exclusive. Event A and B are mutually exclusive as fishes selected cannot be rohu and katla. दोन्ही एकाच ह्याच्यात नसणार आहेत. ओके. सो PA plus B is equal to PA plus PB. So chances of getting row is how much? 180 out of 500. So 180 divided by 500 plus 200 divided by 200 is the number of fishes of katla we get. Probability of 200 fishes of katla we get in a catch. So 200 out of 500. So 180 divided by 500 plus 200 divided by 500 is equal to 380 divided by 500 will be 0.76. So getting a fish, probability of getting rohu and katla in this particular catch will be 0.76 out of 1. Okay. So in a percentage, you can see it is 76% of chances that whenever you put a net in the water, the fish you get will be rohu or katla. Okay. Now, how we can use similar law in case of multiplication? Multiplication law probability. If the occurrence of one event does not depend on the occurrence or non-occurrence of the other event, then these events are called independent events. For example, when a coin is tossed two times, the results of the second throw would not be affected by the result of the first throw. Similarly, sex of child and RH factors are also independent events. Multiplication law of probability is applied to independent event. The word and is used in between the events. So let A and B, जसं मगाशी आपण the independent events with probabilities of PA and PB respectively. Then the probability of occurrence of both the events A and B denoted by PAB is given by PAB is equal to PA into PB. Okay. Instead of addition, we are going to do multiplication or PB into PA. Okay. So very simple formula. There we are doing addition. Here we are doing multiplication. So example, what will be the probability of child getting female and RH negative? Okay. Probability of child being female, that is the PA is 1 half. Probability of child being RH negative, PB is equal to 1 out of 10. So therefore, probability of child being female RH negative is given by PAB is equal to PA into PB is equal to 1 half into 1 divided by 10 is equal to 1 out of 20. So probability of getting a female child with RH negative is 1 out of 20. So these two laws are important of addition, laws of addition and laws of multiplication. Very simple to understand. Okay. A pond contains 200 fishes of which 20 are marked. Second example. A pond contains 200 fishes out of which 20 are marked with some marker or color. Okay. A second pond contains 300 fish of which 60 are marked. In the first pond, 200 fishes, of which 20 are marked. In the second pond, containing 300 fishes, of which 60 are marked, one fish is drawn from each of the pond. What is the probability that fishes drawn are both marked? ओके. किती चान्सेस आहेत की जो फिश हे केलेला आहे, काढलेला आहे, त्यातनं काढलेला फिश हा काय असणार आहे, मार्क केलेला असणार आहे. Let event A is catching mark fish from first pond. B is catching mark fish from the second pond. As event A and B are independent, both the ponds are different. So there is no chances that it will get repeated. Okay. So the event A and B are independent. So PAB is equal to PA into PB is equal to 20 divided by 200 and 60 divided by 300 is equal to 1 divided by 10 into 1 divided by 5 is equal to 1 divided by 50 is equal to 0.02. Okay, so chances of getting this marked fish, if you put the net and get the fish is 0.02 out of 1. Okay, probability we calculate with the probability will be between 0 to 1. So it's a rare event. What it indicates, the rare event to occur. In the earlier case, if you'll see, this is also a kind of rare event, but in this case, if you'll see, the chances of occurring this event is more, that is 0.76. So if you'll go close to 1, that means the chances of occurring the event is more. If you are if the value is remaining close to 0, the chances of getting event is less. Okay, so thank you very much. We have learned in today's presentation in lecture Z transformation, p value, and two laws of probability, the law of multiplication and law of addition. Thank you.